Okay, in this final video, I'm going to talk about what to do if we have a stretch factor greater than 1, and then I will generalize to give you a full-on equation that allows you to just simply use complete the square. If you're in one of my classes, you should be able to demonstrate your ability to walk through the steps, but then after that, complete the square is just a process that you use. So let's start with just a quick example. And the example will be y equals 2x squared plus 8x plus 15. As usual, I like to set plus 15 off to the side and just deal with this. And I'm going to factor out that value of a. Put it out front, and notice that this is an easy complete the square, because what I now have is I have x squared 4x, that's an x plus 2 by x plus 2 square. This corner is size 4. I'm subtracting 4, but notice I did it twice. So my equation now becomes y equals 2 times x plus 2 squared minus 2 times 4 plus 15. Doing a little quick simplification, 2 times x plus 2 squared plus 7, which tells me that the vertex is at negative 2 comma 7, and that I have a stretch factor of 2. All right, so why don't you go ahead and do a quick example? Y equals 3x squared plus 9x minus 5. Pause for just a second while you do that. All right, welcome back. So we set off the negative 5 off to the side. We factored out a 3. We now complete the square for this right here, which gives us, and what I'm going to do is I'm just going to go ahead and do the shortcut version since we know it. That gives me 3 times x plus 1.5 squared minus 3 times, well, 1.5 squared is 2.25. Quit working. Technology is great, except when it isn't. And then we'll bring down our minus 5, and we get y equals 3 parentheses x plus 1.5 all squared minus 6.75 minus 5 is minus 11.75, which tells me that my vertex is at negative 1.5 comma negative 11.75, and that I have a stretch factor of 3, and I could now, if I needed to, graph this very simply. All right, let's generalize. Y equals ax squared plus bx plus c. Setting the c off to the side, I'm going to factor out the a. I'm going to complete the square. Notice that b over a divided in half is b over 2a. Hopefully that didn't throw you, but if it did, divide by 2 is the same as multiply by a half. Subtracting b over 2a squared. So writing this out, I'm going to distribute the a. I've got a times x plus b over 2a all squared. Notice that, and I'll just down in the corner, b over 2a squared is b squared over 4a squared, but then I'm going to multiply this by a, and one of those a's will reduce, and so I'm left with minus b squared over 4a, and then I bring the c back in. the constant term. Guys, some of this may look a little bit familiar. Notice that there's some b's and there's some 2a's and there's 4a's and there's b squared. This is where we get the quadratic formula. And if you wanted to, as an independent exercise, you could set y equal to 0 and solve for x and see what happened. All right, so let's do a quick example using this, and I'm just going to use the same equation that we already did just to see if our generalization works. Well, a is 2, b is 8, c is 15. So we've got y equals 2 parentheses x plus b over 2a. So that's 8 over 2 times 2 all squared minus b squared over 4a plus c. So we get y equals 2 parentheses. 8 divided by 4 is 2. 64 divided by 8 is 8 plus 15. Y equals 2 parentheses x plus 2 squared plus 7. And if we just pop back a little bit to here, 2 times x plus 2 squared plus 7, our generalization works or seems to work. All right, that is everything you need to know about completing the square. So now you can take a standard form equation, y equals ax squared plus bx plus c, and you can rewrite it in vertex or graphing form, y equals a parentheses x minus h squared plus k, to very simply find the vertex at h comma k without having to go through a whole lot of extra work finding the intercepts and averaging and doing all that stuff. All right, thanks for watching. Hope you learned something.